Hi, I'm Ryan Griffin, and this is my homework for week 1 and week 2. I'm going to start this off by talking about relational databases. A database has many entities, and all the entities inside of the database are related somehow. An example of this would be like a fast food database would have employees, maybe tables, um, customers, menu items. Can get a lot bigger and a lot smaller than that. It's just an example. Each entity would be like a customers table, and the customers table would be full of all stuff about customers that are unique to the customers entity. And each table has its own unique identifier, which is, in this case, maybe customer ID, which is unique to each row. In this example, we're going to be looking at a car database, or car model database. Um, Some of the entities required should include vehicle manufacturer, vehicle models, vehicle details, vehicle features, vehicle fuel types, vehicle color. Some of the relationships that are going to be established within this database between these entities, the vehicle manufacturers table can have a 0, 1, or many vehicle models relationship with vehicle models. One vehicle model can have 0, 1, or many vehicle details. One vehicle fuel type can have 0, 1, or many vehicle details. One vehicle can have 0, 1, or many vehicle features, and a vehicle feature can be associated with many vehicle details. So when we draw out these entities and these relationships, we're going to get something very similar to this. Um, we have the vehicle features, vehicle manufacturer features table, vehicle models table, vehicle details table. We have an association table right here with link features to vehicle, and we have the vehicle features table. We'll get more to this relationship in a second. Then we also have a vehicle type table and a vehicle colors table. Each bold word is a primary key, which is a unique identifier to the table, as we stated before. Each highlighted word is a foreign key, which is from a different table, which is used to link the tables together so that later on we can write out joins to pull information from other tables and actually make some deductions from the information we gather from all these tables. I'm going to touch on data types for a little bit inside of these. Each row is going to have its own data type. Usually for things like unique identifiers for primary keys, it's just a integer, which is int for integer. And it's usually an auto incrementing integer which never repeats, so each row is going to have a unique value associated with it. Then there's varchar, which could be used for like manufacturer name or color description. Varchar also has a character length associated with it, which you have to establish when you make the table itself. Um, the foreign keys are just primary keys in other tables, like I said before, that help establish a connection between the two tables. Going back to this many relationship just for a second to help explain what's going on here. We have a vehicle features table and a vehicle details table, but each one of these tables can have, like a vehicle feature can have many vehicle details associated with it, and a vehicle detail can have many vehicle features associated with it. So we have to build an association table, which is a primary key from each table, and together they're going to form the unique identifier which makes up that table. And these are foreign keys, and they're also primary keys, which we kind of highlighted here in this last slide. Jump on some common mistakes with databases. Some mistakes that are pretty common when first designing databases are columns that should be data entries. An example of this would be a table called order status is something that's commonly used. For the columns, you would put open, closed, on, pending, but that would be incorrect. You'd put a unique identifier, which is maybe order ID, and then name and description, and then each of those open, closed, the status types are actually entries inside of that database. So that's how you would fix it. The next one is columns that need their own table. An example of this would be, let's use the example with employees. You want to get as much information about your employees as possible, like what department they work for. But instead of putting department, job title, description, maybe we would make a different table that's labeled a different table that's labeled job description, and there'd be a one-to-many relationship with employees table, because you're going to have more than one waiter, more than one cook, and so on and so forth. What I'm just going to touch on for a second, it's when you don't recognize relationships inside of your database. You don't think about it, and really something that is a one-to-many in your head could be a many-to-many, because there could be several things from one table trying to describe several things from another table, and you need a many-to-many relationship there. And then really quickly, making a column represent more than one piece of information, this would be like having just a name column instead of a first name, last name, middle initial column. And that would not be able to get a whole lot of information, and you wouldn't be able to sort by people with like last names or first names. And then here is the site where I got the database example from.